part, right? Because the other part is just the review. Yep. So this is the important part. Huh? Yes, it is. I'm doing the same thing with this class. Very good. I like it. Check the other class.
Professor,
Yes.
are you going to post the solution to the previous assignment?
It's on YouTube with the previous class. So even though I didn't record it this time, it was recorded twice already with my Thursday class.
Oh.
So if you check out the Thursday class during the lab time, that's already recorded. Okay, so getting back to this. So the mantissa is 1, 2, 3, 4, 5, 6, 7, 8, 9. Exponent is 22. Exponent of 10 is 22. And then exp2 is 0. That's the initial condition. Okay. So you look through this list here and go like, okay, what is the first change? The first change happens here. Okay. So now the question is, what just happened? That actually looks kind of mysterious to me. No, because I shifted 11 out of, shifted it by, the exponent of 10 is adjusted 11 times. Okay, let me think about this. Which means I increased, oh, I know exactly why. Okay. This is actually, I copied from the wrong place. Okay. Give me a little bit of time here because I need to change this. I will explain that later why it is incorrectly printed. Okay, let me open up the other class, Tuesday, Thursday class. I should be copying the assignment from this class instead of copying from the original source. So, but I'll fix it in class. Yep, question? Oh, looks like stretch to me. Okay. Okay, so this is the assignment from the other class, and you can see that the numbers are different. Look at this. And look at the one that I had for this class. What do you think happened? I was using the wrong printf. I was printing as 32-bit unsigned integer instead of 64-bit. So this is correct, okay? This is the correct version. I will fix the one that you guys have to reflect this. But I'm going to use this one to explain it for now, okay? All right. So the transition is, the first transition that actually does anything useful is between these two lines. What happened between these two lines? Okay, guys, you're dropping out of your psychic communication mode again. So what happened between these two lines? Do you see Mantissa being a lot bigger now? Yeah. In fact, how many zeros did I add to the right-hand side? 11. And how did exp10 change? By 11. Okay, so that means every time you multiply the mantissa by 10, if there's enough room to multiply the mantissa by 10, you multiply by 10 to the mantissa, but then you have to decrement the exp10 by 1, which makes sense, right? Because we want to preserve the value being represented. Is that okay? But there's a certain point where you have to stop, because a 64-bit unsigned integer, as big as it can get, is only about 19 digits in base 10. So beyond that, you cannot, just say, oh, we'll just keep multiplying the number by 10, because at some point, you're going to overflow what you can represent using a 64-bit unsigned integer. Which brings us to the next transition. What do you think happened between these two lines? You can see the mantissa is, oh, it's all changed. But something else changed as well. What do you think got changed?
You pulled down a bunch of the exp10s and then added them down to the zeros.
Huh?
Divided by 8.
Divided by 8, that's right. So when you look at the mantissa, it is now 1 digit fewer than before. So we are basically looking at approximately 123 divided by 15.4. That's kind of the ratio of change, which turns out to be about 8. But that 8 is accounted for By the EXP2. EXP2 went from 0 to 3 to compensate for the division by 8 from the mantissa. And guess what? Now that the mantissa is 1 digit fewer than before in base 10, I can multiply it by 10 again. Is that making any sense? So that's exactly what you're seeing in the next transition, which is between this line and this line here. You can see how the only change, or the two changes between these two lines, is the mantissa now has 1 digit more than before in base 10, but EXP10 is now 1 fewer than last time because I have to compensate and maintain the value being represented. EXP2 doesn't change in this case because I'm just multiplying the whole thing by 10 and make EXP10 1 smaller than what it used to be. So you can see how this process is repeated again over here, because this time, we have approximately 15, and then we have about 0.9 here, 0.96, which means I divided the mantissa by 16 this time in order to clear another, well, actually, is that 1 place or 2 places? I'm not sure. It cleared 2 places. That's because if I multiply this by 10 again, that becomes bit 63 is going to be set again. So this is the minimum that I can do to give me one more time, or one more space to multiply by 10 again. Is that okay? So you can basically see how it's alternating between the adjustments of EXP10 versus the adjustment to EXP2. So whenever you run out of place or run out of space to multiply by 10, you keep right shifting in base 2 until there's enough space for another multiplication by 10. Then you multiply by 10 again, adjust EXP10, and then it will be filled up again. Then you shift in base 2 again, make room, multiply by 10 again, and so on. So eventually, we get to this part. So eventually, we get to the point where the mantissa is this. It is using all 64 bits. We divide it by 8, so we end up with this value, which has enough room for one more time of multiplication by 10. Then we multiply the mantissa by 10, EXP10 becomes 0, and then EXP2 is 36, and that's the final answer given this particular case.
Why is there 2 more below it?
That's just the way I tracked my values, but that's okay. There are no transitions between this and this one and this one here. Basically, I have a whole bunch of print statements at various points of my algorithm, and these two are at the end, but that's why it showed the same answer.
Program, you didn't manually, okay.
Right.
So what's the terminating factor? Why is it stopping the process again?
The only terminating factor is you need to get EXP10 to 0.
Okay.
So the terminating condition is similar but opposite to the code that I just presented, because you still want to terminate the loop when EXP10 gets to 0, but you're getting to 0 from the other direction. With the assignment that I just showed, you are going from negative to 0. In other words, you're incrementing EXP10 until it gets to 0. With this one, you start off as a positive value, and you're decrementing it until it gets to 0. So those two loops should be able to coexist, because one would not even start unless EXP10 is less than 0 to begin with. The other one would not even start unless EXP10 is greater than 0 to begin with. If EXP10 is 0, by the time you get to the loop, it's just going to skip it, because if EXP10 is already 0, it's not going to go for a single iteration. Which basically means if you know, where you can insert the new code, you can preserve the old code in your new program and not change its behavior. Is that okay so far?
So we're essentially adding to our old program.
You can if you want to, but the way I test this one is the same way as I test your existing homework assignment. You have a test value, you plug it in, you tell me what numbers you're getting, and that's how I score your homework assignment. All right, so are there any questions about this trace? I'm going to copy and paste it into your assignment because the one in yours is actually incorrect. But besides that, are there any questions? questions. Is this helping? If I show you exactly how the values should be changing?
Extremely helpful.
Okay, cool. That was the intention, is to give you guys, a single test case, but it is showing all the intermediate steps so that you can cross-check your algorithm with this one. Okay, so I'm going to copy this and paste it into your own. And that's it. That's the end of what I want to show you guys tonight. So now you can exit your psychic communication mode. Now this one is due at 7 o'clock on next Monday, so we do not have the lab on next Monday to work on this one. Just keep that in mind, because I know there are procrastinators in this class.
Is this what we're going to be doing on Wednesday?
We can do it on Wednesday, sure. Yeah, we are continuing to do this on Wednesday, so if you, you can do it. You can probably finish it.
Wednesday?
Yeah, I think you guys can do it because of the solution to the negative exponent. You already kind of see the general structure of the whole thing. So this is in a way opposite to that, because you're multiplying by 10 and you're dividing by 2, and that's the only difference, sort of.
Because you can just do it like if it's greater than 0, do this one, or else if it's less than 0, do the other one.
There are quite a few ways to arrange your loop, because you can have inner loops, you can have nested loops to keep doing in a single direction until you're ready for another multiplication by 10. You can also do the if thing if you want to. I personally go for the nested loop, but they're equivalent.
Yeah, I went if. I threw an if in the while loop.
Yep.
Do you mind checking to see if the video uploaded? Because I don't think it did.
You mean for
the exam, the solutions?
Solutions for this class?
Yeah.
That was discussed in the lab right after the exam.
Yeah. On the 19th.
On the 19th. Okay, let me check that. Okay, I think I can stop the one today.